Shown here is our Arduino Uno microcontroller, where we have all of our analog inputs going into those channels. Up here is the digital inputs, which also can be configured as outputs. This here is our 8-channel relay board. For each one of these relays, we have our power source and the regulator connected to it, so we'll be able to electronically control that switch by sending a 5-volt signal from the relay to the relay board.
CO2 regulation system, it's controlled through our regulator, through our tank that's mounted with an ASA with an on-off. Basically, we have our relay that goes, our solenoid that goes to our relay, which will turn it on and off, thus putting CO2 into the system. In the soil, we only have an LED for adding pH up or pH down. And right over here to the right, we have our pH down because we don't need a pH up because tap water is a pH of 8 or 9, so that will give us the added pH up that we need.
For light, we chose timing. We have a timer that sits on the light for 8 hours and off for another 8 hours to have a perfect cycle for the plants. Also, we have a lumen sensor that's in case we have enough light outside, it's going to shut off the light inside and use the outside light.
Located directly in front of the camera on the perf board is the DHT22 temperature and relative humidity sensor. This is mounted on the inside of the environment to give you the current conditions inside the environment. This is our exterior DHT22. This is so we know what temperature and relative humidity is being sucked in through the intake fan.
We use 3 fans. This is our exhaust fan that takes out the hot air or if the air has too much humidity. We have the second fan, which is the circulation fan for the CO2. It turns in when we are feeding CO2 in. And we have the third fan, which is an intake fan that brings in new air to the environment.
Here is our infrared CO2 sensor. The model is a K30, and it will read between 0 and 10,000 ppm, corresponding to a linear voltage output. Our first idea for increasing temperature was a nichrome wire fed into the terminal block you see above. This was not feasible because we didn't have a transformer to provide sufficient amperage to power the nichrome wire. So instead we used this commercial heater, which is ran to our relay and controlled through the Arduino. Shown here is our mister. If you see the green nozzle, that was taken from just a hand spray bottle and connected to the hose accordingly. This is fed into the pump that was shown earlier to provide humidity.
This is our graphic interface. It shows all the states of every single sensor. You can see here the values, real-time values.
Thank you for watching, and if you have any questions, please contact us at the email address provided.